Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph a rational function using symmetry. Now, basically, the way of graphing rational functions is like hard to speak. The way that we graph rational functions, we use a 7-step process. And if you haven't watched my first video, please make sure you watch that because I kind of go in very much detail, step by step, on how to do it. And I'd like to kind of make this video a little bit quicker. And what's going to be benefit is we're actually going to be being able to apply symmetry, which is the first thing we're going to do. But basically, our 7-step process we're going to want to follow because there's so many characteristics of a rational function. Just randomly choosing a table is really not going to benefit you because you want it to be exact on what values you're using. And then what's nice about symmetry is if you have symmetry, then you can just, instead of graphing points, instead of finding points all over, you can just find the points on one side and then use symmetry to find the other points. So going back to our first step process. Now again, I'm going to write down everything still, but I'm not going to always show everything of my work, but I will talk my way through it. But I do want to kind of make these go by a little bit quicker. So if you need to kind of rewind or so forth, please do so. So the first thing we want to do, though, is find our symmetry. So remember, to find symmetry, basically what we're going to do is we're going to plug in f of negative x. And if we obtain the exact same function back, then we have, if we obtain the exact same function back, then we have symmetry about the y-axis. If we obtain the negation of the function, then we have symmetrical of about the origin. So negative x squared is just x squared. And x squared is just x squared. So you can notice that when I plug in negative x, that doesn't change the function. I actually revert back to my original function. So therefore, this is symmetrical about the y-axis. So again, why is this so important? So when it becomes time to determine the points that we're going to plot, we only need to pick the points on one side of the y-axis, and then we can reflect it over to the other side. All right, the next step is to find the x and the y-intercepts. So basically, remember, the y-intercept is going to be when x equals 0. So basically, I'm just going to plug in 0 in for x. So that's going to leave me with 4 times 0 squared divided by 0 squared minus 9. Well, this 0 squared is 0 times 4 is 0. Over 0 squared is 0 minus 9. And therefore, that equals 0. So therefore, the y-intercept is just at y equals 0 when x equals 0. Step number 3 is to find the x-intercept. The x-intercept is when the whole f of x is equal to 0, or your whole y value is equal to 0. So therefore, I have 4x squared divided by x squared minus 9. I'll show again this because it confuses students all the time. If you need to solve for x in this equation, we got to get x squared minus 9 off the denominator. So the way to do that is to multiply by the reciprocal. Doesn't matter what I multiply over here. So therefore, now those divide out. This multiplies to give you 0. So you're left with 0 equals 4x squared. So you divide by 4. And you get 0 equals x squared. Take the square root, and you get x equals 0. So I now have, so I know it's symmetrical about the y-axis. I have a y-intercept at 0. I have an x-intercept at 0. The only thing we need to do is now determine our vertical and our horizontal asymptotes. So step number 4, vertical asymptotes. Remember, the vertical asymptotes is basically when the denominator equals 0. So we go back to our denominator and say, all right, I'm going to set my denominator and set it equal to 0. So I say x squared minus 9 equals 0. Now I just go ahead and solve. So I add 9 to both sides. I'm left with x squared equals 9. Take the square root, take the square root. X equals plus or minus 3. Remember, when you're introducing the square root to solve, you got to take the positive and the negative values. Last one, number 5, is going to be the horizontal asymptote. So remember, the horizontal asymptote, we need to look at the degrees of our function. So we have 2 and 2. They're exactly the same. So 2 equals 2. So when the degrees are exactly the same, you take the horizontal asymptote is a over b, which is the coefficients. Well, here I have 4 is the coefficient of x squared. And then what's the coefficient of x squared? That's going to be 1. So I basically have 4 over 1, which is just 4. So I'll write that as, so I have, and y equals 4. OK, so now, before we go on and get a little bit farther, let's go ahead and plot the information that we have. So I'm at positive 3 and negative 3. 1, 2, 3. Okay, those are going to be asymptotes. Okay, and then I have a horizontal asymptote at 4. 1, 2, 3, 4. Okay, and I have an x and a y-intercept at 0. Now, the reason why, again, this is so important is because rather than just randomly choosing numbers to plug in for your function, I know that I'm going to have to choose values to the left and to the right of every vertical asymptote. But since I have symmetry about the y-axis, I can just focus on one side and then reflect it over. So that's exactly what I'm going to do. So I'm going to choose 2 points to the left and to the right. And basically, kind of think of this again if you're going to create a table of values. Okay? Just like if you were going to graph x and y. We know if you plugged in -3 into this function, you'd get 0. That would be undefined, so that's an asymptote. But so we're going to want to figure out, that's -3. We want to figure out the values for -5. We want to figure out the values for -4. And then I'm going to pick the value for -2. Okay? And then we're just going to plug those values. So how do you figure out what those values are? Well, you plug in the x value in for x and then find y, or what f of x is. So I'm going to solve for f of -5, f of -4, and f of -2. Okay? So again, remember, ladies and gentlemen, when you're doing this, basically this is just like me using a table of values, plugging them in. But I'm using function notation to represent that. Now, I'm not going to actually show myself plugging them in, because I did that before, and it takes a little long time, and I want to speed this apart. So I am going to say it out loud and show some of my work here to help you out with that. So if I plug in -5, I have -5 squared is going to be 25. 25 times 4 is 100. And then 100. Then a -5 squared is going to be 25. 25 minus 9 is going to be 16. So let's just do 600 divided by 16. Now, the other thing to remember is when you're dealing with decimals, or when you're dealing with graphing, I always like to stay away from decimals. I always like to keep with fractions. But it's very important. We're just graphing. We're just trying to find we're just trying to find approximate values. So getting the exact value is okay not to always have, because we're just going to be plotting them. And I don't know why my calculator won't turn on. So I'll go back to little grade here and pick one of these fun ones up. And I just want to make sure I have the right answer. So 100. Of course, this one doesn't work. Divided by 16. What the heck? .25. So I have 6.25. Let's do -4. -4 squared is +16. Positive 16 times 4 is going to be 64. And then -4 squared is 16. 16 minus 9 is 7. So let's do 64 divided by 7. And that gives me, let's do it. 64 divided by 7. What the heck is, OK, now this one turns on. 64 divided by 7 is 9.14. So I'll just round that to 9.1. And then at -2. -2 is +4. 4 times 4 is 16. And then -4, so that's 16. So then that's -2 is 4. 4 minus 9 is going to be -5. So let's go and reduce that. Divided by -5, I guess I probably could have done that in my head, -3.2. OK, so again, we can use symmetry, so we can use just half of this. So basically, these are coordinate points: 6.25, 9.1, and -3.2. So let's plot the points. At -5, I'm at 9.1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Way up there. Oh, no, I'm sorry. At -5, I'm at 6.25. At -4, I'm at 9.1. OK? And then over here, at -2, I'm at -3.2. So again, for my graph, remember I connected them. I want them to approach the asymptote. So it's going to show like a little hyperbola. It's going to approach the vertical asymptote, and then it has to approach the asymptote. Here, I got to connect these points, but they can't go up because then it's going to kind of go to a dead end. So it's going to have to look like this. So now, if I just reflect these points, then I can just use symmetry now to make my graph. Is that nice? Isn't symmetry nice? So I only had to use 1, 2, 3 points instead of finding 6 points. OK, so now let's go into the next example here. And actually, I wrote this wrong because I made a mistake on this video. So I had to recreate it. So I didn't actually. So the actual original problem is f of x equals -2 divided by x squared minus 1. Now, the reason why I had that 2 up there instead of, because what I was telling in my first video was if you have a -8 over 4, that's the same thing as -8 over 4, which is equivalent to 8 over -4, which all equal -2. So when you have a negative in front of a fraction, just put the negative in the numerator or in the denominator. So what I did was I said, I'm going to put it in the numerator, because I'd rather put it in the numerator than put it in the denominator and have to negate a binomial, which would not be fun. It's not really hard. It's just extra work. OK, so I'm kind of running out of space here. So I'm going to try to do my best to really scrunch everything in. So the first thing we need to do, step number 1, is again find the symmetry, f of -x. So I get -2 divided by -x squared minus 1. Well, that gives me -2 divided by x squared minus 1. So again, we have y-axis symmetry. Sweet. Number 2, we want to go ahead and find the y-intercept. So I do f of 0 equals -2 divided by 0 squared minus 1. So that becomes -2 divided by 0 minus 1, which is -1, which equals +2. So my y-axis is y equals 2. Then I find the x-axis. 0 equals -2 divided by x squared minus 1. So here, when I multiply, this one gives me a very nice one. I like this. So I multiply by x squared minus 1 on both sides. And what I'm left with is 0 equals 2. Well, 0 does not equal 2. So guess what? There's no x-intercept. So the graph is never going to cross the x-axis, which is possible. And that's cool. All right, step number 4, vertical asymptote. So in this case, we're going to do x squared minus 1 equals 0. Right? You take your denominator, set it equal to 0. Here I go ahead and solve. Add 1 to both sides. Take the square root. Make sure you include the positive and the negative. X equals plus or minus 1. Step number 5, horizontal asymptote. Now again, we look at the degrees. Now this one you say, well, there's no degree in the numerator. Well, yes, there is actually. You can actually write x to the 0, because x raised to the 0 is equal to 1. And -2 times 1 is 1. So therefore, we have 0 and 1. And obviously, 1 is greater than 0. So whenever the degree in your denominator is larger than the degree in your numerator, we have an asymptote at y is equal to 0. That's why the graph doesn't cross. Now, there's times where you're going to have a horizontal asymptote and the graph will cross. But in this example, it's not going to cross at 0. So now we need to go ahead and plot our information. Now, again, remember, we have symmetry. So we only need to focus symmetry on one side of the graph. But let's plot what we have for you first. First of all, we know that the y-intercept is going to be at y equals 2. We know that the x-intercept does not exist. We have vertical asymptotes at +1 and at -1. Oh, this is step number 6, by the way, is plotting the information. And a horizontal asymptote at y equals 0. OK, so now I need to determine some points. And again, I'm just going to choose points to the left and to the right. So I have -1. I'm going to plug 1/2 as a point. I'm going to pick 1/2. And then that's -1, so -2 and -3. So those are going to be your 3 points I'm going to want to figure out. So I'm going to do f of -3. I'm going to do f of -2. And I'm going to do f of 1/2. All right, so let's see if we can plug them in. So I have -2. So -3 squared is 9. 9 minus 2 is 8. So I have -2 over 8, which equals a -1/4. So at -3, I'm at -1/4, which is like almost at the asymptote. Let's do -2. -2 squared is +4. +4 minus 1 is 3. So I have negative 2 over 3. Oh, that's a negative 1/4. OK? And negative 2/3 is almost to 1, but it's not quite there. But it's on the it's getting there. OK? And then let's do f of 1/2. So 1/2 squared is going to be 1/4. 1/4 minus 1 is going to be a negative 3/4. So I have a negative 2 divided by a negative 1/4. Oh, no, sorry, negative 3/4. If you remember in my first video, how do you get rid of the fraction in the denominator? Multiply by the reciprocal. OK? How do you multiply negative? That's going to go to positive, so let's just multiply by the negatives. So then that multiplies to give you 1. So you're left with a negative 2 times negative 4/3. Negative 2 times negative 4/3. Put the 2 over 1. Multiply across. You get a positive 8/3. So if you remember from last video, that was positive 2.6. So 1, 2, 3. So 2.6 would be up here. So again, remember, we have to have the shape where we have to have the graphs approaching our asymptotes. So you can see here, these two, they're going to be approaching. We're going to have a nice little hyperbola here. And then over here, I'm looking at this, and I'm saying, all right, that's going to approach. Remember, it can't cross, so we know it's going to have to rebound. So then you just reflect your points. Because remember, it has symmetry. So whatever it looks like on the left side, it's going to have to look like on the right side. So there you go, ladies and gentlemen. That is how you use symmetry to help you graph two rational functions. Thanks.